Assalamu alaikum warahmatullahi wabarakatuh. Today we're going to do the last part for the chemistry Regent January 2020. I'm going to explain everything in details. We're going to do part C. Again, as I said before, I don't care about the passage until or unless I have a question related to the passage. If I cannot figure it out, I have to go backward and try to figure it through the passage. So compare question number 66. Compare the chemical reactivity of nitrogen and argon based on Sir Resimus experiment. Without looking there, if you're looking for the reference sheet, argon is here. That's a noble gas, so doesn't participate in the reaction, while nitrogen is a non-metal gas, so it's participating in the reaction. What does it mean? Nitrogen is more reactive than the argon. Nitrogen is more reactive than the argon. Okay. Question number 67 compares density of nitrogen gas to the density of argon gas. So that's easy one. I go for the reference sheet. I'm looking for nitrogen gas. Here is the nitrogen gas. If you're looking there, that's the density for the nitrogen gas. And if you go all the way down, here is the argon. So argon 0.0016, that's 0.0011. So what does it mean? Nitrogen is less than in density than argon. State in terms of valence electron why noble gases that Sir Ramsay discovered have similar chemical properties. So if you're looking for the noble gases has the same number over there, the same number of valence electron, 888, according to the octet rule. So that means they have the same chemical properties because they have the same number of valence electrons. A said trend at standard pressure of the boiling point of the noble gas. If you don't know, go for the reference sheet. Look again for the noble gas. So I know I have helium, neon, argon. So I'm looking in page 10 here. So the helium boiling point is 4. After that, neon boiling point is 27. After that, argon 87. After that, if we're going all the way, it should be krypton 120. So if you look, every time the boiling point increase. So by increasing the mass, boiling point increase. So by increasing the atomic number, the boiling point increase. I use that reference sheet. Question number 70. So I skip also the passage. How many times greater hydronium ion concentration in lake water? Oh, so that's I have to go back to read the passage. The passage says that the normal rainwater pH is 56. So here is the rainwater. Rainwater pH is 5.6. So its concentration, hydronium ion concentration, is 10 to power negative 5.6. Now for lake water, it's 4.6. So its concentration is 10 to power negative 4.6. To get how many greater the lake over the rain, so 10 to power negative 4.6 divided by 10 to power negative 5.6 is going to give you 10. So it's 10 times greater than. It's 10 times greater than. States the color of methyl orange in the sample of rainwater. So the rainwater, as we said, the pH is 5.6. So I'm going for the reference sheet. Methyl orange Methyl orange. I'm looking for the methyl orange should be here. Oh, methyl orange here. So methyl orange is if it's more than 4.4, it's going to be yellow. If it's more than 4.4, it's going to be yellow. So if you're looking here, the pH is 5.6, so it's for sure is going to be yellow. On table G, describe what happened to the solubility of sulfur dioxide as the temperature increased from 10 to 30 Celsius. So I'm going for table G. So he's directing me to table G. I'm looking for table G. Here is table G. I'm looking for sulfur dioxide. Here is the sulfur dioxide. So at 10, it was this amount. And if you're going for 30, it decreases. So what happened? So the solubility decreasing by increasing the temperature. Question number 71. Write the empirical formula for acetylene. So the acetylene is C2H2. So the empirical formula means I'm simplifying. So CH. That's empirical formula. Second part. Draw model diagram represent the phase of the oxygen at least 6 molecules. So O2, I have 2 atoms together. That's the 1 molecule. So I should have 6. So it is 1, 2, 3, 4. Sorry, this one should be connected. 5, 6. So here is the answer for question 75. Now question number 76 to determine the mass of 25 moles. So I'm going for the reference sheet, getting the formula, the molar, the number of moles. Here is the number of moles equal to the given mass over the gram formula. That's the one I'm going to use. So number of moles equal to given mass over gram formula. So he giving me 25 and the gram formula is 26 and here is the mass. So mass equal to 25 times 26 giving me 650 gram. 650 gram. Excepting term of bonding. Why hydrocarbon used in cutting is classified as alkyne. So if you're looking here, the alkyne here is the alkyne CN H2N minus 2. So if it's C2 H2 times 2 minus 2 C2H2, and in that case it's going to have triple bond. So that's in the term of bonding. So it's follow the formula for CN H2N minus 2, and in that case it has triple bond. It has triple bond. Question number 75. 78. 78 was one of the critical questions. Why? Look here. Compare the thermal energy of 10 gram sample of water at 25 Celsius to the thermal energy to 1000 gram sample of water to 25. So the majority are going to be confused, but if you're looking here, the thermal energy is here. Q equal to MC delta T. They are in the same temperature constant. They have the same C, specifically it's the same material, specific heat. So the thermal energy directly proportional to the mass. So as the mass increase, as the thermal energy increase. So that's the explanation for that question. So the one with the 1000 gram is higher in thermal energy, is higher in thermal energy. Okay. State what happened in the potential energy of the molecule in a solid sample of hexane at -95 Celsius as heat is added until hexane is completely melted. So when you convert from one form to another form, you gain energy. You gain energy. So conversion affected energy. How? So if I go from solid to liquid to gas, I add heat, I add energy. And if I go backward, I subtract energy. So like when you want something to melt, you added heat. When you want something to vaporize, you adding heat. But if you want something to deposit, you cool it down. So where is this energy? This energy is going to be internal energy. Like this energy is going to convert it like potential energy for the molecules. So what's going to happen? The potential energy will increase. The potential energy will increase. Question number 80. Determine the vapor pressure for water at 69 Celsius. So I go for the vapor pressure table. Here is the vapor pressure for the liquid. You wanna it at how much? 69. So look here, that's 50, 55, 56, 57, sorry, 50, 60, 65, 70, sorry, again, I have to count again, sorry. So 50, 55, 60, 65, 70. So he said at almost 69. So I'm going to assume like 70. I'm going all the way up and it should be here. That's the water. That's this is a 70. It should be here. So if you're taking the reading, I messed up all this. I have to do it. Sorry, and I'm going to do the video. So here it's again. Here is a 70. I go to meet the water and I go all the way to the left. So if you count 10, 20, 30, so it's almost 30 kilopascal. Kilopascal. Now, explain in terms of molecular polarity why hexane is nearly insoluble of water. That's easily. If you're looking for carbon and hydrogen, the carbon electronegativity is almost 2.6 and the hydrogen is 2.4. You're going to find that in the reference sheet. If you don't know where, I'm going to go to the reference sheet. Here is the hydrogen electronegativity, sorry, it's 2.2 and the carbon is 2.6. Okay, so that's 2.2 and that's 2.6. So the difference in the electronegativity is 0.4, means it's non-polar. Non-polar and non-polar compound cannot be dissolved in water because it doesn't have any charge. Doesn't have any charge. Now, explain in terms of molecular formula and structure formula why 2,2-dimethylbutane is isomer of hexane. So here is the hexane. C, 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 C. 6 because it's hexane. And all these are H's. So if you look at C6, and if you count the H 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, H14. Now I'm going to draw the 2 dimethyl butane. So 1, 2, 3, 4. And dimethyl 2, so CH3, CH3. And after that, the others are H's. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So C6, H14. So they have the same molecular formula, the same number of carbon and hydrogen, but different structure formula, like as we saw in the answer. The last question. Again, I don't care about what's the passage about unless I need it. It says the oxidation number, so let's go. So that's what I need. It says the oxidation number, that change in oxidation number of oxygen. So here it was -2. When it's a molecule, it's 0. So it changed from -2 to 0. Compare the number of electron lost. So we have conservation means I have equal number, equal number. Determine the number of moles. So now I'm going for the overall equation. The ratio is 1 to 2. So if I have point, so 1 to 2, 0.004, so the other one must be 0.008. So the answer 0.008. That's the end of that part for the chemistry Regent for January 2020. Hope you understand. Wish you a good day and good luck. Assalamu alaikum wa rahmatullahi wa barakatuh.